So question 5.
I think it's a similar question. Let's see what we're given. Okay. A line contains a point. Oh, sure. This is an important kind of thing. A line contains a point and is perpendicular to another line. Okay, so the point that this contains is 3 and minus 4. Great. So we may have one point. But we also know it's perpendicular to something. Well, the fact that it's perpendicular to something is going to tell us its slope. Once you know some line and you know that your line is perpendicular to it, you know its slope. If we know its slope and we know the point it goes through, then it can't get away from us. We can write the equation. So what is this other line? The other line. Okay. The other line is 5x minus 6y equals 4. Okay. I want to find out the slope of that other line. Because do you remember the relationship of two lines that are perpendicular to each other? Remember how the slopes relate?
Yeah, their slopes of 1 and negative 1.
The slopes are, the product of the slopes is minus 1.
Oh, of the two, the
Yes.
slopes of equal negative 1,
The
yes.
product of the slopes of two lines that are perpendicular is minus 1. So if I know the slope of this guy, I'll know the slope of the thing I'm looking for. Let's just find out what the slope of this is. So minus 6y equals minus 5x plus 4. Could care less about the 4, by the way. Don't care about this intercept. I'm just going for slopes. So 6y is equal to 5x minus 4. So y is equal to 5/6x minus 2/3. Okay, again, the intercept, I have no interest in this intercept. This is what I'm looking for. The slope of the other line. Slope of other line is 5/6. Right? So that tells me what the slope of our line is. The slope of our line times the slope of the other line has to equal minus 1. That's because they're perpendicular. Just as Cassandra said, that the product of the slopes has to be minus 1. So if the other line slope is, I'm looking...
It would be negative 6/5?
Yes.
Or
Negative.
5/6?
Nope.
The 6/5?
Right.
5 and 6.
You
Oh, it's 30
invert,
and 30, yeah.
you invert the slope and take its
Reciprocal.
minus. It's the negative of the reciprocal. Okay, so now we know the slope of this line that we're after. Okay, because we found the slope of the other line, we know the slope of the other line times the slope we want to find is minus 1. So, therefore, our slope has to be something that when multiplied by 5/6 you get minus 1, and that would be minus 6/5. I think you'll agree that minus 6/5 times 5/6 is equal to minus 1. So, okay, great. So what does it want us to do? Write the equation of the first line in point-slope form. Well, now it's kind of a piece of cake. Y minus y0 equals m times x minus x0. And here is our x0, and here is our y0. So y minus a minus 4 is equal to the slope, which is minus 6/5 times x minus 3. Now let's clean it up a little bit. Y plus 4 is equal to minus 6/5 x minus 3. That's about the only cleanup I need to do. That's it. That's point-slope form. That's it. Okay, so graphing. We okay? Right up to this point? Okay.
No comment.
There's no comment.
Well, no, it just seems like there should be a simplified way to do that. I know that you've requested point slope form, and you obviously had a reason for doing it that way, but it makes it so complicated. It's got to be an easier way to assess that than to do it in that form.
That actually seems pretty simple.
Well,
Pretty simple.
Yeah.
okay. Well, we can graph right off of this if we want. Well, we know we're given the point, so we can at least put 1 point down. We know we're given 3 and minus 4, 1, 2, 3, and minus 4, minus 1, minus 2, minus 3, minus 4. Okay, that's the origin, don't think that's a point. So that's 1 point, and then we know the slope. We calculated the slope was minus 6/5, so that means it's got to be something running downhill, and it means I go over 5 and down 6, right? If the slope is minus 6/5, so I'm going to go, I'm going to go backwards. I'm going to go 1, 2, 3, 4, 5, and then up 6. 1, 2, 3, 4, 5, 6. And I think you'll agree that that is a negative slope for sure. And it's got to be a slope kind of close to 1. I think you'll agree that minus 6/5 is pretty close to minus 1. And it should kind of look minus 1-ish. Minus 1 would be a 45-degree angle. So that's about right. So again, the rise over the run is 1, 2, 3, 4, 5, 6, and the run is 1, 2, 3, 4, 5. Yep. And that's pretty much the graph of the equation. Right? It was pretty easy because
So how many points were those, because you have 5A and 5B, was that 10 points? or-
No. 5A and 5B, I think it might have been a 6-point question.
A 6-point
And
question?
each part was 3 points.
Okay.
Okay, so now we move on to question 6.
right? Now, question 6 gave people, I was really surprised, it gave people a lot of trouble. And there were some answers that, frankly, I'm going to be harsh and say that the answers were absurd. I'm just going to say it, and I hope to convince you, I don't mean to insult anyone, but if you think about it, you'll see what I'm saying here. Okay, so we're given this chart, and we're asked for each linear system, fill in the rows of the table. Well, the questions that are being asked are whether it's consistent or inconsistent, whether the system is consistent or inconsistent, if no solution exists, if one solution exists, if there's 2 solutions, exactly 2 solutions, are there infinite number of solutions, or if it's impossible to determine the number of solutions.
But you wanted us to do that based on just looking at them.
You may have to put them in a form where you can see what the slopes are.
Right, yeah, there was no graph to be able to graph them,
Yeah.
and then be able to tell
Yeah.
if they were one solution, many solutions. That's the problem I had anyway.
Well, let's go through
Were
it.
you able just to look at them and get it?
No, I don't think you can look, well, some you can. Let's go through it. So, linear system, and we have consistent or not consistent. That's question 1. Then, no solution? Solution, no solution, one solution, 2 solutions, infinite number of solutions, or, I don't know how you say this, impossible to determine. Okay, and I gave you 3 linear systems to look at. Okay, first off, right away, how many linear systems have exactly 2 solutions? Not of the ones I've listed, in the whole world, since the beginning of time.
Have 2 solutions?
Yeah. How many linear systems have 2 solutions? None. I've done this, I must have done this so many times that illustrate that linear systems are lines on a graph.
And lines can cross and intersect in only one place. And I've challenged everyone in the class to come up with a way that they can get two straight lines to intersect in two places. I can't picture it.
Well, I was thinking of two solutions as an X and a Y.
No.
I was thinking of as once you've solved the formula, once you've solved the problem, then there'd be an X and a Y.
Right, that's
So
one.
that would be, so I don't look at that as two solutions.
No.
There's X would equal, this amount, and Y would equal this amount, so that would be,
No.
that's what I was thinking, but anyway.
Okay, well, disabuse yourself of that terrible thought.
Okay.
A solution is the solution set. It's X and Y that satisfies both equations simultaneously. So there are never two solutions in a linear system. So right away, that's a giveaway. I mean, there's no such thing. Okay, what about this? Impossible to determine the number of solutions. Was there ever a point since the semester began that I said, oh, you can't tell how many solutions? You can't determine it. Did I ever say that? I mean, did the book ever say that? No. We always determined that there was either no solutions, a unique solution, or an infinite number of solutions. Why? Because lines can either cross at one point, or at no points, or at an infinite number of points, if they're collinear. Those are your only possibilities for straight lines. And given the system of linear equations, it's going to be one of those three, and it is possible to determine it just from the slopes.
So that's not.
That's not, I guess I didn't make that clear, but that's not possible. So your only issue is it a situation with no solution, one solution, or an infinite number of solutions? Okay. And consistency and no solution kind of go together. If there's no solution, the system is inconsistent. And if there is a solution, whether it's one or infinite, then the system is consistent.
So again?
Okay. If there's no solution to your system of linear equations, it's inconsistent.
Right.
Otherwise, it's consistent.
Okay.
Okay. So let's look at our first linear system. 3x equals 2y plus 3 and minus 4y plus 6x minus 3 equals 3. Okay? That's it. Now, that second equation can be simplified a lot. It was minus 4y plus 6x minus 3 equals 3. Well, come on. Let's put the 3 on the other side at least. Minus 4y plus 6x equals 6. Let me divide by 2. I get minus 2y plus 3x equals 3. Okay? And now compare that to the first equation. The first equation is 3x equals 2y plus 3. Okay, this is the first equation, and this is the second equation. I'm going to convince you now that that's exactly the same equation. It's exactly the same thing. Ernesto.
What did you divide by 2 again?
Why? Because I could. Because, I want to simplify it.
Okay.
Now, the second equation can be written as, let me take the y, the 2y over to the other side. So I have minus 2y plus 3x equals 3.
So it's the same one.
It's the same, these
That's
two.
an infinite.
Yes, it is certainly consistent because it has an infinite number of solutions, and there you go, done. It's the very same line. Okay, now what about, let's look at the second pair of equations. 4 minus x plus 3 plus y equals 7, and x minus 1 plus 2 minus y equals 0. Okay, again, this needs some simplification and a little bit of cleanup. So we've got 4 minus x plus 3 plus y equals 7. All right, well that's, to me, says minus x plus y equals 0, because I got 7 on both sides. Okay, so I cleaned that one up. The second equation is x minus 1 plus 2 minus y is equal to 0. Well, let's clean that up. That's x minus y equals minus 1, right? X minus y, and then over here I've got plus 1. Put that over on the other side, it's minus 1. Now let's look at these two equations. One says this, y equals x, doesn't it? This says y equals x. This says y, well, let me invert the sign here. Y minus x equals 1. So this says y equals x plus 1. Okay. The first equation, when I reduce it down, says that y is equal to x. That's because y minus x is 0. So y is equal to x. Okay, that's nice and valid. But the second equation, when I reduce it, says that y is equal to x plus 1. What does that tell you?
No solution.
No solution.
There's no solution.
No
Why there's
solution, no,
If you-
right.
Can you graph that, why there's no solution?
I sure can. I sure can. The first equation is y equals x. That's a
That's that one, yeah.
The second equation is y is equal to x plus 1. They
Parallel.
both have slope 1. This goes through the origin, and this goes, its y-intercept is 1. They're parallel lines
Other parallel.
because they have the same slope, but a different intercept. So two lines that have the same slope and a different intercept, they're not going to cross anywhere.
So there's the,
There's no solution.
There's no
And that
solution.
would be inconsistent. No, not consistent, inconsistent. And no solution. In fact, maybe to make this, make a check mark there. Okay. Oh, the last one is x plus y equals 2, and x minus y equals 1. Okay. Well, let's look at this. Oops, x minus y. Okay. So let's put x plus y equals 2 into slope-intercept form. So that would be y equals minus x plus 2. So the slope of this is minus 1. That's good to know, because the next equation is y minus x minus y equals 1. So minus x plus y is equal to minus 1, so y is equal to x minus 1. Okay, so, did I get that right? Yes, I got it right. So the slope here is minus 1, and the slope here is plus 1. What does that tell you?
so it's perpendicular?
Yeah, and that's good observation. It's perpendicular, and they're going to cross. I mean, the fact that it's perpendicular says, bang, you got a solution.
Because -1 and 1 would be 0, though, it wouldn't be -1.
Where do you see negative 1 here?
Well, we've got -1 there, and then we've got 1. We got a slope of, the slopes have to equal -1.
The product of the slopes,
Uh-huh,
has to be minus 1 to be perpendicular.
right.
The-
So that would be 1 over 1, -1 over, so you're multiplying it?
If I multiply, yes, multiplying, you take two lines and you multiply their slopes. If it's minus 1, they're perpendicular.
Oh, -1 times 1 is -1. Oh, I see, okay.
Yes, you got it.
Okay.
But a larger point is this: the slopes are different. Any two lines that have different slopes have got to cross somewhere. So therefore, that is one solution and definitely consistent. Okay? So the reason I was saying I was critical of this, that I found people saying, oh, it's impossible to determine the number of solutions.
People just guess because they didn't have enough time.
Yeah,
probably.
they must have been guessing,
I
but
waited
then...
until the end to do that, and I just was like, I didn't have time to go through and try to do all the work that pertains to how I could get to the answer.
Okay. All right, so that's all there is to it.
I mean, that may be, I don't know if that's true, but...
Is, if you ever see it again, I mean, I'm not saying you will, but if you ever do, you know to kind of put things in slope point form, or slope-intercept form, so you just get the slope.
Well, see,
And if
that's
the
why this
slopes
is
are
good,
different,
yeah.
you've got solution.
Yeah,
And if, a unique solution, if the slopes are the same, it's either going to be inconsistent, or it's going to be infinite, depending upon if the intercepts are the same or not. So you want to always be thinking graphically. And
I was
that's,
hoping there would be a little graph so that I could figure it out, but I just didn't, even I wouldn't have had time anyway, but anyway.
Okay, so we're ready to go to problems 7 and 8.